Welcome back. Today is day 1 of our triangle relationships unit. Today we'll be exploring and proving the triangle sum theorem, and hope you enjoy. Oh yeah, it's that time again. We have some math problems here and we need you to do them now. Pause the video, complete the problems, and return to the video when you're done. Complete each statement. That's what we have to do. So we have a little word bank there at the bottom. So I'm just going to draw a little couple arrows in here and match up what goes where. So the first one, actually I'll just write in A, complementary angles. Well, I know complementary angles are two angles that have a sum of 90. So actually the first one's A. Nice. All right, linear pairs. Linear pairs, that's going to be, I'll call that one B. So a linear pair is going to be, if two angles form a linear pair, then the angles are supplementary. That's actually the linear pair postulate. Perfect. So that's that one. Supplementary angles are two angles that add up to 180. So that's going to be this one, two angles. If their sum measures is 180, perfect. And the last one must be vertical angles. Two angles whose sides form opposite rays. All right, that's a tough one right there. All right, so that shouldn't be too bad, but we have a second do now. On this one, again, working on our vocab. So let's see if we can figure this one out. So angles 3 and 5. So angle 3 and 5, that's going to be this angle and this angle. So when I look at this, I'm like, oh, those are alternate interior angles. All right, perfect. So the first one should be alternate interior angles. All right, what about 4 and 8? Four and 8 should be corresponding angles. So that shouldn't be too bad. Oh, I have to erase it before I write. So this should be corresponding angles. What about 3 and 6? 3 and 6, 3 and 6. So those two, well, they're between the lines, so they're going to be interior angles, and they're on the same side of the transversal, so these are same side interior angles. 1 and 8. 1's out here, 8's out here. You can see that they're both exterior angles. So this will be same side exterior angles. And the last one, did it again. Sorry. And 2 and 8, 2 and 8, that's this one with this one. These are on opposite sides of the transversal, so these ones are called alternate exterior angles. Okay, good little easy review of our vocab from last unit, so hopefully that's a good reminder, good refresher. Your job is to move these little vertices around a little bit, and then also try to answer some of these following questions. So here's the 3 questions. What are the relationship between the blue angles? So move these around so you can grab and you can touch on these points. So move them around and see what happens to the blue angles as you do that. What's the relationship between the orange angles? That's question 2. And the last one is, what is the relationship between one blue, one purple, and one orange angle? So what is the relation between that? So go ahead and mess around with that and then answer the questions below. All right, so in this problem, now that we've done the GeoGebra, we've kind of seen the relationship between the, we should already know that triangles, the interior angles will add up to 180. But this time it says, prove that the sum of the interior angles of a triangle is 180. And they give us some hints. So we have to do actually what we saw in GeoGebra. We have to draw a line DC parallel to line AB. So I need to draw a line. This is going to be as best as possible. So there's a parallel line. Perfect. All right, and I'm going to call this point D. There we go. That's line DC. All right. Now, the next thing it tells us to make their life a lot easier, let's number some of these angles. So let's number these angles. I'm going to number this 1, 2, 3, 4, and 5. Okay. So we have angles 1, 2, 3, 4, and 5. Now, what were we given in this problem? So in a proof, well, we weren't really given much in this one. We're given a triangle, so we don't really have to say that. I guess we can say we're given triangle ABC. So we weren't given too much in this problem. But what are we trying to prove? We're trying to prove that those interior angles, they add up to 180. So we're trying to prove the measure of angle 2 plus the measure of angle 4 plus the measure of angle 5 is equal to 180 degrees. All right, so now what? So the next part here. So what was the first thing we did? In order to do this proof, the first thing we did, we drew a line. So I'm gonna write this out. So line DC is parallel to line, what is that, AB. Now, how do we know that? Well, we drew it like that, and we're saying that they're parallel. And we're gonna do this by construction. So you are allowed to construct things into your problems if you want. So if you added a piece, so just by construction, now we know this. And let me just state that these are parallel by putting arrows. So we have an arrow on each one. So now that says, hey, these lines are parallel. All right, so now, once we did that, now we should be able to kind of do the problem like we did earlier. So what did we see earlier? Well, the first thing we noticed about these parallel lines is that it created some angles here. So this angle 1 was the same as this angle 4 here. And how do we know that? Well, those were just alternate interior angles. So let's write that. So let's write the measure of angle 1 is equal to the measure of angle 4. And how do you know that? It was alternate interior angles theorem. And you have proven this before. That's why it's a theorem. So remember, anytime you prove something, now it's a theorem. So we've proven last unit that alternate angles created by parallel lines will always be equal. They'll always be the same. And now also from the GeoGebra, you should remember, you should recognize that these two angles are going to be the same. So those two angles right there, 3 and 5, we saw that from the GeoGebra. That was a nice little hint. So the measure of angle 3 is equal to the measure of angle 5. Same exact reason. So these are exactly the same. So now, remember what we learned about parallel lines. When you have parallel lines, then the corresponding angles are equal, the alternate interior angles are equal, and the alternate exterior angle. So again, this is a review just from last chapter. Now I have this whole other box over here on the side here that kind of has nothing in it. So I'm going to color it in just like we saw in our little GeoGebra. So I'm going to color this in. Now, what can you conclude about angle 1, 2, and 3? Well, we should know that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180. You should know that already because those three angles make a straight line. So we're going to say a reason for this. How do we know that those add up to 180? Let's say definition of a straight angle. So they complete a line, but again, it's not a pair. So definition of a straight angle. And we're basically done. We just have to wrap this one up. So we just have to combine all these into something that makes sense right now. So check this out. Over here, you know that measure of angle 1 is equal to measure of angle 4. So that means we can substitute right here where it says measure of angle 1, and we could put a 4 in there. You also know that measure of angle 3 is equal to measure of angle 5. So that means where it says right here, measure of angle 3, we can substitute that with the measure of angle 5. So let's do our substitution and let's see what we're left with here. So this now says, I'll use the colors so it matches. So now we're going to say the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 has to equal 180. All right, what's your reason? My reason is going to be substitution. And this is your reason. This is how you're going to set this up. And now, what does that say? We have proven what we were trying to prove. We have proven that 2 plus 4 plus 5, it's in different order, but 2 plus 4 plus 5, those angles have to equal 180. And guess what? Now we can write our theorem. So let's write a theorem from this one. Triangle sum theorem. What is the triangle sum theorem? The sum of the interior angles is 180 degrees. That's our theorem. So now, instead of saying that triangles equal 180, you're going to say, if we ever ask you anything related to that, you're going to say, oh, it's triangle sum theorem. That's how we know. We've actually proven it, and remember, it's a theorem because you have proven it. You've actually gone through the process of proving this. All right, hope that helps.